Okay, so our last video was on percent problems that were growth, where our b-value was greater than 1. On these ones, this video here, it's about percent problems that we're going to have decay, which again means our b-value is between 0 and 1. So the first thing we're going to do is we're going to talk about what that means for this. So really it's the same process that we had for growth, except, like I said, that b-value is not greater than 1. It's between 0 and 1. Well, for growth, what we did last time is we did 1 plus the percent divided by 100. Okay? Well, today, if I want that to be smaller than 1, okay, instead of doing 1 plus, we're going to do 1 minus. So we're going to do 1 minus our percent over 100. And when we subtract that small decimal, what's going to happen is that we're going to get some decimal, some b-value, that is between 0 and 1. It's going to work in our problem. Okay? Remember that, because that is key. You have to switch it to the decimal, do the percent divided by 100 first. We talked about that key skill in the last one. Because if you don't, you're going to end up with a negative b-value, which can't happen either because it has to be greater than 0. Okay? It has to be between 0 and 1. So we're going to look at 2 here first. We're going to write our model. We're going to practice writing the equation. And then we're going to do 2 full examples where we have to write the model and then answer up a follow-up question. Okay, so here we're going to write our model first. You bought a car, a $20,000 car that depreciates. That's our clue in our first read-through that this is decay, in value by a rate of 9% each year. Okay, so second read-through. We're going to identify our A, which is 20,000, and then our b is going to come from this 9%, but remember we're going to do 1 minus 9 over 100, or 1 minus 0.09, and we get 0.91. That's our b-value. So our model, y equals 20,000 times 0.91 to the x power. Okay, it's that easy. Again, the only difference from last time is that we're subtracting that decimal, that rate is a decimal, instead of adding it. So our next example here, you purchased stock for $5,000 and it lost, that's our clue that this is decay, its value at a rate of 13% each month. So second read through, identify the A. We purchased stock for $5,000 and it lost its value at a rate of 13%. Our b is going to use that, so 1 minus 13 over 100, or 1 minus 0.13. I can put that in a calculator if I need to, and I would recommend it if you need to. With adding, you're just tacking the decimal onto a 1. It's really easy. Subtracting, it's a little different. Sometimes you might get confused, so I would use the calculator if you need to. For this one, you get 0.87, so that's our b value. To write our model, y equals 5,000 times 0.87 to the x power. And it's that simple. Now we're going to do 2 more examples, but this time we're going to do follow-up questions with them. So we're going to start out by writing our model, but then answer that follow-up question that comes along with it. So example 1. The population of a large city is expected to decrease, that's what tells us it's decay, at a rate of 15% each year. If the city currently has 150,000 residents, how many people would you expect it to have after 15 years? Okay, so next read through, identifying A and B. If the population of a large city is expected to decrease at a rate of 15%, so our B is coming from this. 1 minus 15 over 100, 1 minus 0.15, use my calculator, 0.85. That's my b value. Each year. It currently has 150,000 residents. So there's our a value. Let's write our model. Y equals 150,000 times 0.85 to the x. Okay. How many would it have? How many, I left out a word there, residents would you expect it to have after 15 years? So there's our x value, that's our time. So y equals 150,000 times 0.85. Now years matches years in the beginning part of our problem, so we don't have to determine the time. It is the 15, and we can just plug it into our problem. It also says to round to the nearest whole person. We talked about that with growth. We're going to round people or populations to a whole number, money to 2 decimal places. So I'm going to take my calculator here, plug it in my calculator, 0.85 to the 15th power, and I get 13103.13287. Now again, we're rounding to the whole person, so I'm looking at that number, and it's a 1, which is less than 5, so my answer, 13,103 people. Now, a note in Schoology, the label's already going to be there, so you don't need to type it. You also don't need to type commas in there if you don't want to. You can. I will take that answer. Schoology's set up to take that, but you don't have to. Okay? So that's a full-on example of percents as a decay problem. Let's look at one more. There are 500 fish in a pond that a toxin has leaked into. The toxin kills the fish at a rate of 26% each day. How many fish would you expect there to be at the end of 2 weeks? Round to the nearest whole fish, which makes sense because this is a population, so a whole number is what we're going to round to. Well, the key word here, kills, means it's going to be a decay problem. Okay? I'm going to read through it again, and this time I'm going to identify my A and my B. There are 500 fish, so there's my A, in a pond that a toxin has leaked into. The toxin kills the fish at a rate of 26% each day, so my B is coming from this. So 1 minus 26 over 100, 1 minus 0.26, which gives me, I'm going to use my calculator here, 1 minus 0.26, gives me 0.74. That is our B value. So let's write our model. Y equals 500 times 0.74 to the x. Okay, yep, that is correct. Now, the follow-up question, how many fish would you expect there to be at the end of 2 weeks? This is important. This goes back. Our times don't match here. In the pre-part of the problem, we have days, but in our follow-up question, we have weeks. So we need to switch that weeks into days. Well, 2 weeks, I know there are 7 days in a week, and I have 2 of them. So really, 14 is going to be my exponent here. Okay? And I did not put many of these in Schoology. This is just a refresher on how you change that time frame if you need to. 0.74 to the 14th power. Again, we're going to use a calculator, so 500 times 0.74 to the 14th. I ended up with 7.3826 and a bunch of decimals here. Really, I'm not concerned with all those decimals because we're rounding to the whole fish. So I'm looking there at the 3, and 3 is less than 5. So my answer is 7. That's a pretty drastic change in that fish population. We started out with 500, and at the end of 2 weeks, we're only left with 7 fish. That's a pretty potent toxin. Hopefully someone would have done something about that along the way to save that fish population. But there's our example. Okay, example 2, another population example. Now money works the same way. I don't have an example 3 for you. Money works the same way. Okay, you're doing 1 minus your percent over 100, but with money you round it out to 2 decimal places. Okay, so recap, make sure that you subtract your percent from 1 in order to make it the correct B value. 1 minus our percent over 100. That is for decay. Just a reminder, growth is 1 plus our percent over 100. This makes it bigger than 1. This makes our B value between 0 and 1. Second part, always write your model first. This is where we get our 2 read-throughs. Okay, then answer up your follow-up question. That's our third read-through to our problem. Okay, so really on these, I have it set up just like with your growth ones. You have a small set where you're just writing the equation, just writing the model, so you should do 2 read-throughs. I have another set where you're writing the model and then you're answering the follow-up question, so you should be doing 3 read-throughs. If you have any questions, please post them to the discussion board. Like I said, you do have a short Schoology assignment that follows this. Use the examples here and what we did with growth to help you figure that out. Okay? But ask me any questions if you need to. Good luck.